Hello, I'm an old guy and I do maths. Today we're looking at the graph of y equals log x, and I've set up a Cartesian plane here with a couple of points of interest, this point 0, 1 and this point 1, 0, and I have a dotted line through here which is the line of y equals x. Now there's a reason for all of this. Hopefully you have been told that logarithms are the inverse of exponentials. So what I'm going to do is I'm going to draw in the graph of y equals e to the x. And that looks like this. I could have chosen another exponential, but it probably confuses things when it comes to dealing with the logarithm. So my badly executed drawing of y equals e to the x looks like this. It passes through 1 because if we make e to the power of 0, we get 1, and the x-axis is an asymptote. This function will approach, the graph of this function will approach this line but never touch it. Now, let's take a look at what the graph of y equals log x looks like. Now, I guess you're going to have to trust me for this. You can put this into a graphing app, or use your calculator to graph this. But this is the graph of y equals log x. And hopefully, although my drawing leaves a bit to be desired, hopefully you can see that this and this are reflections of each other in this line, which is one of the characteristic definitions of an inverse. When you invert a function, the graph of the original function and the new function should be reflected in the line y equals x if you have found the true inverse. So what happens is x and y get swapped around, and x maps onto y and y maps onto x, as you can see here. So 0 maps onto 1, 1 maps onto 0. But let's think a little more deeply about this just before I finish. And by the way, I should mention that the asymptote is now the y-axis. You will see that this is approaching the y-axis, but not crossing it. And there are a number of reasons for why that is the case when the function is in exactly this form. It is possible to move this to the left on this graph, but we'll not get into that today. So the question is, why, if we put 1 into this, do we get 0? Well, that comes down to basic logarithms. So let's just assume that we're in base 10. We'll say that, and what we want to know is what is the log of 1 in base 10, and that is 0. Simple as that. Something to the power of 0 will give you 1. 10 to the power of 0 will give you 1. And that is why this ordered pair here is as it is. I think that's all I want to say. This is just an introduction to logarithm graphs. There'll be probably a lot more videos in this series, because I'm sure that it pops up certainly in the high school curriculum, and undoubtedly in various subjects at university. So these are graphs that you ought to get familiar with, and you ought to understand how they move about and how they're affected in the same way that you understand how the graphs of functions such as this, or the graph of a function such as a quadratic or a hyperbola, is affected by various changes to it. Okay, well, I hope this was gentle and a helpful introduction to what the graph of the log of x looks like and why it looks that way. If you found this useful, please like and subscribe, and I'll see you next time. Bye.